Hello everyone, Chintan again. I just wanted to introduce you a new software today, which is the AnyLogic uh, software. It's let me bring it on the screen, and then I'll get going on that. So the software name is AnyLogic 8.9.3 Personal Learning Edition. This is a software which we will be looking at as part of our unit related to the designing principles for automated processes. Essentially, when we are designing the any system, um, we will like particularly the automated manufacturing processes, which we learn in previous units. This uh, principles are important for analyzing and designing the systems, such as if you are, let's say, designing manufacturing cells using robots, let's say in warehouse scenario or at some other place, let's say palletizer system. At that time you would have to understand more about how would the entire system behave in conjunction with each other. So, for example, if you have a warehouse system and if you have, let's say, four or five conveyor belts in it, you would have to understand about the sequence and how would it behave. And then you can also you should also think about many factors, such as what if one of the conveyor system or one of the process is overloaded, what would be the timing required for one system in conjunction with the other system and stuff like that. So it's more like, you need a tool which allows you to create those type of processes, simulate those type of processes, and essentially run them to see how they behave in conjunction with the the PCs which are used to build that system. So it's more like design concept. Okay, and um, you know if I look at the software which is available, there are many softwares available, but I like this Any Logic software because it has got like free license, personal license available for students, academia, and then they have like ton of examples also shown or like shared with us. So without going into the details about how the software has, like, what are the components, I would like to focus more on the example related to the warehouse. Okay, so uh, out of this examples, I chose one example related to warehouse conveyor, because if you might have seen like many systems where you will have warehousing available, um, Walmart, you name it, like Amazon, um, big uh, warehouses where you will have this type of systems deployed, right? And probably you would have a chance to work there, or maybe you would be lucky to at least have a visit there. So then at that time you will see that uh, this example matches with what you will be looking at in the industry, like warehouse, industrial warehouse. So this software, as I said, it's pretty nice. It has got different components, like uh, first of all, this is like the design of the system. There are multiple parts to it, like they have this block diagrammic representation of the system, kind of a flow diagram. There is some backend program written, which we are not gonna focus at this point because it has got Java and stuff like that. um, our task today is not to understand how to create this type of models, because it will take a lot of effort and time to create this type of models, and probably you would have to go through entire course related to any logic, learning any logic. Having said that, it is not difficult as well. Like If you by any chance want to go through this software, in fact, they have one book available, Any Logic in 3 days. You can learn, you can go through that and understand at your convenience as well. But for this course where we are focusing more on the aspects related to the processes, various process manufacturing processes involved and how do they behave, um, I would not recommend you go through the effort of understanding any logic. But as I've said, like there is a book freely available written by Ilya Grigorov, and I think the any logic in 3 days is quick course in simulation modeling. And then they have already explained all the modules, how to create three different modules like agent based module, system dynamics modeling, and discrete event modeling. The three types of systems. In fact, there is a fourth one also related to pedestrian modeling, like airport model, or maybe like people walking on the street type thing, right? So it's like not this software is not just for modeling the manufacturing process. It can be used for modeling many different types of phenomena. Okay, so without going into detail of that, I would just go back to our interface of the any logic and talk about the warehouse conveyor system. So we have got this warehouse conveyor model in which we have got different conveyor systems. So this is like a 2D representation of a warehouse. It's kind of a top view of the system. We have got the pallet conveyor here. So you will have robotic arm. This is a robotic arm which brings the pallets on this, on this conveyor, and then it puts onto this in-feeding conveyor. In-feeding conveyor brings like the pallets and like boxes from this conveyor, two conveyor systems. One is from here, second feeds from here, and then it feeds, everything is combined onto this conveyor system, in feeding conveyor, which feeds to three different food rack, like three different product racks. So the first one, left one, is food rack, the second one is beverage rack, and the third one is dish rack. Okay, from this, collecting systems, the racks, it has the ability to store this, uh, food boxes or beverage boxes coming from the infeeder conveyor system. And then you have human available, like intervention here, like three people are taking the boxes coming on this from the racks, and they are ensuring that it goes to the conveyors, feeding the packing lines. Okay, but what should be the order, and how should we do the packaging? That will be decided based on the order coming from this. Okay, so we'll have labeling coming out with the on the boxes, and then invoice will also be included, like in it, meaning, and there are screens available with this operators, like there are operator screens on which they will have the order available. Everything is automated, so they can look at the invoice, they can look at, understand the what it needs to be, which material needs to be packed. The product goes out. If the box is empty, it goes back to the feed line. Order is checked here using a camera system. It goes to the packing lines, and then it further goes to the and then there is a shipping label is added here. Then it goes to sorter, right? You might have seen this type of system in warehouse, or if not, this has a 3D view which will help you understand that. So what I'll do is I'll run the model. So without touching anything, you can open this from the examples, like so. You can also open any other examples, like this AB market as the supply activity based costing analysis, stuff like that. Um, I won't go into other model right now while I'm talking this about this model, but it has got these files available, which I would request you not to touch at this point without having understanding of it. But you can definitely run this model using this F5 button or like this run button. So if I run it, it will start the simulation, and we will have three um, or in fact four things available when you click the run button. Okay, so as you can see, this is the 3D view. I can zoom out. When while I'm running. This warehouse. This is a 3D view of the warehouse, showing what I explained. It has also got some settings. So the settings is important to understand, and that is the basis for our lab, where I would request you to play around with this, set point settings, and understand how this entire system behaves, observe what is happening, and answer a few questions. Okay, as part of the lab. Um, so let's see what are the settings. So the settings are minimum goods per order, how many goods you can have in one order. Okay, so it can be one, it can be two, depending on the so if I'm setting my limit saying that minimum order can be one, minimum order can be two or three, let me take minimum order to be three. Okay, so the way I was thinking to design this lab is that we will start with some number. So I'm saying we'll have uh, minimum goods per order 3, maximum goods per order 5. We'll have the order inter arrival time uh, to be 25. Okay, what does that mean? So it's like it is the time required for the orders, the time between two orders, inter arrival time. So 25, keep it 25, meaning it's fast. Okay, 25 within 25 seconds, the second order is coming into the system. Reorder level, let's put reorder level to be 45. Is there any repeat order? Reorder level 45, right? So with this setting, I would like to run this system. Okay, but before that, like to read this, that this is a simplified model of a warehouse with a conveyor system. Pallets with food, drinks, and dishes arrive at docks for delivery. Right, onto the pallet conveyor system. This pallet conveyor system. These goods are then taken from the pallets by either robots or workers and placed on infeeding conveyors. This is infeeding conveyor that take them to the racks. These are three racks, right? The third conveyor network simulates order picking and simple sorting system. So this is the third conveyor system which picks up the order, right? And then it goes fills to the simple sorting system on the right side. Cartoons are delivered to order picking lines where operators put the ordered goods inside boxes. If there are other goods that need to be added or to the order, then the cartoon is conveyed to the next picking line, which is different. I'll show you later. Otherwise, the cartoon is moved to the packing line and then to sortation system. The model is built with the material handling library. There are some libraries available built in this if you want to build a model based on that, and focuses on simulation of conveying goods and simple inline operation. So I will run this using this. I can run it. I can stop this too as well. I can slow it down using this minus sign, speed minus sign, speed up sign, or I can do entire 5 minute, 5 hour. This, by the way, this can run for 5 hours simulation, and it will look at all the things related to how would it behave, and I'll show you. Let me run this. As I've said, I can speed this up and put it in virtual time mode as well, which will allow 5 hours of the simulation. I'll share that later, but let me run this. So when I click on the run button, it will show me 3D view of the entire system. As you can see, like pallets are coming in, feeder is bringing those boxes to these racks. The orders are coming with the boxes and invoice. Um, you can see there are screens for available with the for the human intervention. Conveyor systems are bringing the packets back to the this feeder here, and then it brings the uh, completed pallets, sorry, the boxes to the sorting system, right? um, Fantastic system, but I wanted you to observe what is happening on each and every conveyor system. For example, like this system versus this. uh, so I would request you to watch this as well as the 2D view. Okay, look what's happening here. I would like you to observe not the logic but statistics as well. What's happening over here? What is the order picking time distribution? So this tells you the average time for order picking, full order processing time. How much time does it take for the full order on in general? Um, what are the order states per minutes? Orders in progress versus waiting orders. So this says orders are in progress. Amount of goods per order. In this case, we selected, uh, I think we selected, how much was the minimum one? So we selected minimum goods per order equal to 3, minimum goods and maximum goods per order to be 5. So on an average, you can see what's happening here. Mostly the orders, like 60% of the orders are around two, and around 40% of the orders are three per order, three goods per order. This graph shows you like stored goods states per minutes, reserved good versus unreserved goods, and then this graph shows you good storing time distribution or in minutes. So like how much storage time for goods is there in minutes. So and this tells us like unavailable goods per types, whether the material is available during the time or not. Store unreserved goods per type. What is the like? It seems like food is taking the lead on the orders. Goods in process order per types: food, beverages, dishes. So again, another bar chart. Sorry, the pie chart available. By the way, these are all known as bar charts, uh, versus these are like pie charts. So, and this is the pre-ordered waiting time distribution. Things will change. If you look at here, you will see you need to observe what's happening here, and I would like you to write down your observation. You can take the screenshot after 5 hours. So I don't want you to waste 5 hours time. So to expedite the process, what we can do is we can go here and first of all put the mode in statistics, and we can go to virtual mode, which will run it as fast as possible. So it will simulate 5 hours of data, and then finally it will say, you know what, I'm done. There is an error. But by the time you'll have good amount of information on an average, what's happening in the system, right? So I would like you to take a screenshot and put it in your system, like put that in your lab manual. And after this, doing all these things for by changing the uh, simulation parameters, So by stopping it and by changing the simulation parameters, like make minimum goods per order 1 versus order interval time 45. So with various combinations, I would like you to run this system and understand what's happening. Okay, your observations are important, uh, based on these graphs, as well as based on the visual inspection of what you see in this system. I would like your inputs in the group. You can discuss, what's happening. You can log that, and then you can present to the other groups after the observation is logged. Okay, so that's pretty much it for this lab. Hope you will learn something new related to the designing principles and understanding of how the entire system behaves, what can be the pitfalls of one system getting blocked, or one system behaving not in conjunction with the rest of the system components, right? So this is what I wanted to share. More is like on you'll go through this and hopefully understand the basic concepts of designing the manufacturing processes. Okay, thank you.